Okay, this is going on page 95 when we're done. This is a review. It doesn't matter who taught you geometry, what level of geometry you took. This is part of geometry at all levels from everybody. So should definitely be a review. If you need more of a review than what I'm taking you through today, Khan Academy would be a great place to go. But I think for most all of you, it'll be fine. We're not doing every single one of these. So to set up your trig ratios correctly, whether you're doing right triangle trig or whatever, what's our little acronym for that? Sohcahtoa. So it is Sohcahtoa. And it doesn't do you any good if you don't spell it correctly, because that's kind of the whole point of it. So make sure you can spell it correctly. Some of you may be at the point where you don't need to write it down. You just know what it is in your head, and that's fine. But it doesn't hurt to write it down. But again, make sure you can spell it right. We're just finding the value of x. So here we're looking for side lengths. If you have a missing side of a right triangle, you can use Pythagorean theorem. You can use special right triangles. If you have the appropriate information, clearly here, neither one of those things work. So we move on to trig. So you identify which angle you want to use. It's pretty easy. It's 32. Could I find the other angle and use it? Yes, but what's the point, right? We're not just use that one. When, if I was teaching you this from scratch, I would make everybody label everything at the beginning until we can get the hang of it. I think most of us should be past that at this point. You still need to label something. If you still feel like you need to label more than what I'm doing, that's fine. But we know that if this is the angle, then across from that, this is the opposite side. And then across from the right angle, that's the hypotenuse, right? So I'm using opposite and hypotenuse. Which trig ratio would that be? Sine. So you always take the sine, cosine, or tangent of an angle. So it's the sine of 32. It's equal to the opposite, which is 11, over the hypotenuse, which is x. For this example, and this example only, I'm going to make you write down the next step, and I'm going to write it down so we all know where it's coming from, and then we'll get to skip it. I need to get x by itself. If I just divide by 11, that doesn't help me because that would leave me with 1 over x. But I'm going to multiply both sides by x, so I get x times the sine of 32. And that's equal to 11. And then I need to get x by itself, so what do? Divide by the sine of 32. So x is equal to 11 divided by the sine of 32. And now again, we're still not touching our calculators, not now, and just this is still going to be a few minutes. But we get to this point. Now, if you notice what happened, we started here, we ended here. Sine 32 and x switch places. That's going to happen every single time. So it's pointless to do this step every single time. But the first time, I want you to see that it's where it's coming from mathematically, so you don't think there's some sort of magic or that you're allowed to just willy-nilly switch things whenever you want to, because it does not always work out for you. But this is our exact answer. To get the actual decimal, we'll use the calculator in a minute, but again, not quite just yet. Okay? All right, so what are you doing? Let's look at number 2. Here is my angle. So this is the opposite side. This is the adjacent side. Which trig ratio is that? Tangent. So I'm going to take the tangent of 75. That's equal to the opposite, which is x, over the adjacent, which is 21. This time the variable's in the numerator, so to get x by itself, all I have to do is multiply. So this gives me x equals 21 times the tangent of 75. It's the same thing as 75, the tangent of 75 times 21, but it's safer to write it this way for parentheses reasons and all kinds of things. Okay, we good? Those are the only 2 ways it can be set up. X is in the numerator or it's in the denominator if you're looking for a side length, because the 2 side lengths that you're using are what come up in that fraction. So go ahead, and I want you to set up these 2. Go ahead and get to this spot in both in 3 and 4. Basically get to the exact answer and then stop. And see whether or not you agree with me. Do we agree on that? Yes. All right. Any questions at this point? Okay, so now I want you to use your calculator. We're going to go back to number 1. And I want you to just type in number 1, get a decimal, and stop, and then wait for everybody to get there. And of course, you always want to double check that you're in degree mode. We already did that, but you know, if you're using a different calculator or whatever. So that 11 divided by the sine of 32. You've got a couple of options here as far as typing it in. It is fine to type it in just like this, right? And if I do this, whether I close the parentheses or not, it doesn't matter. My other option is to put it in fraction form. So if I hit 11, and then the fraction thing is right here below the calc button, right up here at the top. So I could hit the little fraction thing, and then I could put sine 32, so it looks exactly like it does on my paper. But if I do it this way, you have to close the parentheses. Otherwise, it's going to give you an error. You get the same answer either way. I don't know that it's worth it on this one to make it look like that, but if I had a lot of stuff in the numerator or a lot of stuff in the denominator, sometimes doing it that way makes it easier, but really it probably makes it harder to do it that way, but you get the same answer either way. And then we have to round to the nearest thousandth. How many decimal places is that? 3. So this is going to get me to x equals, what is it? 20.758. Oh, and I forgot to ask you some other questions. Don't get ahead of me. Don't type the next one in yet. Because what I was going to ask you here is to tell me something about the answer before we typed it in the calculator, and I forgot to do that. But what is something, I know you know what the answer is now, but before typing it in, I don't necessarily expect you to have a concept of what 11 divided by the sine of 32 is. However, looking at the picture, you should know something about your final answer. What would be something we'd know before we typed it in? Has to be greater than 11. You agree with that? Because it's a hypotenuse, so it has to be bigger than 11. If I get 7 point something, I did something wrong somewhere. The other thing is, this angle is 32. If this angle was 30, then what would x be if this was actually 30 right here? $22, because this would be the short leg and this is 2 times the short leg, so it would be 22, right? So since this is pretty close to 30, this should be close to 22, right? So there's actually 2 things I know, that it has to be bigger than 11 and it should be close to 22, right? And that's what I got here. Now, I'm not saying take 5 minutes to overanalyze your picture every time before you type anything in, but the more you think about those things as you're going through it, even if you don't stop to think about it before you type it in, the more likely it is when something weird pops up and you do something wrong, you're more likely to catch it because you're used to looking at things that way critically and thinking, oh wait, that has to be about that number. Or no, it can't be like 37 because it should be close to 22, and that's pretty close, you know, that sort of thing. Just start thinking through things that way, and it will help you understand all of it as you go along. So before we type anything else in, let's just look at the rest of these. What is something you can tell me about x? Is what? Okay, it's greater than 21. Why? Because it looks like it? Can we go with that? No. Because 75 is the bigger angle. If this is 75, what's the measure of this angle? 15, right? So the bigger side is across from the bigger angle. Don't go by the way the picture is drawn because they are not always accurate. But since 75 is bigger than 15, then this side length has to be bigger than 21. Not only that, but 75 is a lot bigger than 15. So I would expect a number that wouldn't be like 23 or 24. It's probably going to be a lot. It should be a lot more than 21. All right, so then here, what can you tell me about x? Less than 30. And sometimes that's either all you can come up with or all you can come up with quickly. I mean, we could sit here and overanalyze it and come up with an estimate, but we don't need to do that. But you at least should know it's less than 30. And then here, what can you tell me about this? It should be close to 15. Okay? Not just that, should it be bigger or smaller than 15? Bigger. And that's honestly the answer I was expecting to get today, but every period somebody has said that it's close to 15. But that's really a better way to look at it because this is 41. If this was 45, this would be 45. It'd be isosceles, right? And so since this is kind of close to 45, it shouldn't be too far off from 15, right? So it should be kind of close to 15, but it's going to be bigger because this angle here would be bigger. Okay, so those are things that you need to be able to tell from picture, you know, from, not pictures, but from the problem itself, because sometimes you're not going to be able to find the answer, but you at least know it can't be this or can't be that. Sometimes that's helpful to get you where you need to be. Okay. All right. So I want you to go back to number 2. Let's type that one in. 21 times the tangent of 75. And then what happens there? Gives you an exact answer. Before you typed it in, did you expect that you would even possibly get an exact answer there? Probably not, right? Because our exact answers for these things have been coming from 30, 45, 60, right? But if I take 60 and half of 30, I can get 75. So the 75-degree angles and those multiples are something that could be put on the unit circle too. We don't need to, but you can still use the unit circle to come up with some other exact ones. But as much as I love exact answers and we want things in exact answers all the time, when you get to this part on one of these kind of questions, we're looking for our Home Depot answer, right? Like, I need a board this long, and if I walk into Home Depot with that answer, they're going to look at me like I'm crazy. Like, it's better than saying, I need it to be 21 times a tangent of 75 feet long, right? This is pretty much just as bad. They don't know how to measure that, and, neither do I with the rulers I've got. So we want the decimal. So this calculator, although it's great because it'll simplify square roots for you too, but sometimes, even though it's simplified, you still want the decimal. If you look above the delete key, you see this SD with the little arrow thing? If you hit that key right there, it'll toggle back and forth from the decimal answer to the exact answer. And it'll just go back and forth for you. Okay? So make sure you know where that button is, because there'll be times where you get that exact answer, but you really did want the decimal that time. So you can get it. And if you have a decimal and it won't toggle, well, that's because it was an irrational number. Maybe it was the sine of 37 and it's not going to be exact for me, or whatever, pi, whatever. So when we do that and we get the actual decimal there, then our answer is x equals, we should get 78.373. Now on these answers, just having x equals is fine. They didn't give us units, so it's just a value and it's okay. And just having x equals is perfectly fine because it literally says find the value of x. But when you just make up an x to have something to label, that's when you got to be careful about how you answer it. All right, go ahead and type in these next two. Don't wait for somebody else to do it. Make sure that you're typing it in so I know you're typing it in correctly. Or typing it always makes it sound like I'm saying incorrectly. No, I want you typing it correctly. Into the calculator correctly. And then when you may have time to finish the assignment in class today, but let's say you don't, and you won't always be able to finish these. You need to have something to be able to work these, to type these into outside of class. Now, I know some of you have 83, some of you have 84, some of you have Inspires, some of you may have one like this, some of you just use your phone. Like, all that's fine, but you need to understand that some calculators, and just for instance, the default scientific calculator that comes on the iPhone, which if you didn't know, on the normal calculator, if you just turn it sideways, it turns it into a scientific. But that one is one of the ones where you have to type things in backwards. And what I mean by that is, instead of saying tangent of 75, I have to do 75 and hit the tangent button, right? And so when you have to type things in backwards, that makes some of these things a little bit more difficult to type in. Once you have whatever it is you're going to use outside of class, take numbers 1 and 2 and type these two things in and make sure you get these numbers. That way first of all, for sure you're in degree mode, and second of all, you're typing things in the right order. That way you don't go do your homework and you have all the exact answers right, and then everything ends up being wrong just because of the calculator you used, right? So always kind of double check yourself if you're unsure of the calculator. I mean, if you know how to do it because you've been doing it, that's different. But if it's, one that was shoved in the back of the drawer, or you haven't worked problems like this on your phone, whatever, just make sure that you're doing it correctly there. All right, so let's look at number 3. We should have gotten, 27.615. Do we agree with that? Yes. And then 4 is 17.256. Yes? We all feel good about that? Beautiful. We don't need to do 5 and 6. So flip your calculators upside down again. I'm going to talk through the bottom ones before we start typing things. So that's us finding side lengths. We might also need to find angle measures. Hang on, this will catch up with me in a second. What? Thank you. Given the trigonometric value of an angle, use the corresponding inverse trigonometric function to find the measure of the angle. So when I do this, if I have that the sine of theta is equal to x, and so I know that sine of theta is equal to 0.73 or whatever it is, or the sine of theta is equal to 5/6, I need to get what the angle is. So I've got to get sine away from theta. This is not multiplication. Just like if I had the square root of x equals 3, if I want to get x by itself, does it make any sense to divide by the square root sign? No. And I'm pretty confident none of you would even try to do that because that would like make absolutely no sense, right? Because this is not multiplication. Neither is this. So I don't get to divide by sign, right? That's an operation. So you have to do the inverse. The inverse of this would be squaring it. The inverse of sine is sine inverse. So I take the inverse sine of both sides and I get that theta is equal to sine inverse of x. Or the inverse sine. Or it can also be called arc sine. Arc tangent, arc cosine. They all mean the same thing. It looks like sine to the -1 power, but that's not how you would ever say it because that's not what's really happening there. So that means that theta here would be cosine inverse of x, and theta here would be tangent inverse of x. Okay. So since we always take the sine, cosine, and tangent of an angle, the inverse is always taken of the ratio of the side lengths, which could be given as a decimal just depending on the situation that you're in. All right, so let's do these. We set these up the same way. You identify the angle you're using. Well, that's the one I'm looking for right there. This is the hypotenuse. This is the adjacent side. So which trig ratio am I using? Cosine. So the cosine of theta is equal to the adjacent, which is 18, over the hypotenuse, which is 23. Now, that doesn't reduce, but even if it does, I don't care. But make sure that you're answering the question that's being asked. If it asks me for the cosine of theta is 18 over 23. I'm done. It's not asking me for that. It's asking me for actually the measure of theta. But there are times when you're asked for the cosine ratio, but some of you go too far and find theta and nobody even asked you for that. Okay, so be careful with that. So just pause right there. We're not going to type that in the calculator just yet. And then I want you to go ahead and label and get to this part right here on number 8. Oh, wait, I didn't finish it. Duh, I'm sorry. I don't want the, because I don't want the cosine of theta. I want theta. So what do I have to do? Cosine inverse. Yeah, sorry. Theta is equal to the cosine inverse of 18 over 23. Now I'm at the exact answer part of theta. Sound like a cat, didn't it? So get to that part on number 8. Okay. So, do y'all agree with that? Okay, so if you're going to take the sine or cosine inverse, would you ever take the sine or cosine inverse of an improper fraction? Think about that. Think about how you set up sine and cosine and whether or not it could ever be. No? Why not? Good. For both of these, the hypotenuse is the denominator, right? So if the hypotenuse is always the longest side and it's always the denominator, I sure do. She's leaving? Okay, thanks. If it's always the hypotenuse and it's always in the denominator, then it will never be an improper fraction. Does that make sense to you? So if I ended up with sine inverse of 21 over 5, something's wrong with that. For tangent, because it's opposite over adjacent, unless it's an isosceles triangle, one of the two sides is bigger than the other. So depending on which angle you're using, you could totally have an improper fraction, but not for these two. That, again, kind of helps you catch your mistake. All right, so go ahead and let's flip our calculators over. On pretty much at least on every calculator I've ever seen, I'm not saying on every one that exists everywhere, but the inverse ones have been right above the actual functions themselves. So if you just hit shift cosine, that'll get you the cosine inverse of 18 divided by 23. And then what that gives me, it gives me 38.49995, blah, blah, blah. but I am trying to round to how many decimal places? 3, the thousandth. So I'm rounding to here. So when we round, we look at the one after it, right? So this 9 rounds this 9 to 10, which rounds this 9 to 10, which rounds this to 5. Does this 5 then round this 8 to 9? No, but I will have people swear that that's what their teacher taught them. No, totally not what your teacher taught you. Maybe what you took away from it, but no. So what this gives me then in the end is that theta is equal to 38.500. And those zeros are important because that tells me that there's something else out there. If I got exactly 38.5 in my calculator, then my answer is 38.5. But this right here is saying we rounded it and they just happen to be zeros. And then it is degrees because there are units there. Okay. All right, so then go ahead and get the next answer in there. For theta over here. I get 13.774 degrees. Do we agree with that? Yes? Anybody have any questions at this point at all? All good. All right, beautiful. So go ahead and flip it over. And we're not going to do 9 through 12. I don't think we need to. Would you agree with that? Like, you're fine with all this? Okay. But we are going to do, I want you to jump to 13. We need to do a couple things down here. So we were told on the front to either find a side length or find an angle. Here it says solve each triangle. That means you find everything you have that we don't have yet. And you can do things in different orders, you know, whatever works for you is fine. Finding the other angle is pretty easy. We can start with that. How do I find the measure of angle B? What could I do? Okay, so I could do 72 plus 90 minus 180. Won't that give me a negative number? Yeah. Okay. Do I have to add these two together? No, because the acute angles of a right triangle have to be what? 90. They have to be complementary. So the measure of angle B is just equal to 90 minus 72. Now, is that a pretty easy thing to do? Yes. Are you allowed to use a calculator when you're doing trig? Yes. Then use it, okay? If this is something that you are allowed to use a calculator for, then use it, even for stuff like this. Now, should you be capable of that without a calculator? Yes, and we all are. Do we all mess up on stupid easy stuff sometimes? Yes, we do. So don't mess something like this up just because you didn't use a calculator when it was sitting right in front of you, okay? Because it's not that they're evil and you should never ever use them. You just shouldn't be so reliant upon them that you can't function without them. That's where I'm concerned. So measure of angle B is what? 18 degrees. And I say that because, so on the notes, I work them out and I work them out again, and then if I took these questions from certain things and I have a key, I'll check myself, and anytime I ever check myself with a key that I have, if they don't match, then I always assume that I'm wrong. But on this one, the other person that worked it out had the angle R was 66 degrees, and it's not, right? What is it going to be? It'll be 56. But that is the exact kind of mistake that y'all make on questions like this. Because because it is easy. You're not thinking about it, you just write it down. And so that's why I'm saying basic stuff, not a bad idea just to type it in to double check yourself. All right, so then we need to find the other side lengths. And I need to find both of them. So this is my angle. This will be the opposite side. Oh, well, this is my angle. This is the opposite side. This is the hypotenuse. This is the adjacent side. I can't find the opposite and the hypotenuse at the same time, but I am going to need to find them both. So I'll start with the hypotenuse. I have to use the adjacent side because that's where my information is. So if I'm using adjacent and hypotenuse, what trig function is that? Cosine. So it's going to be the cosine of 72 is equal to the adjacent, which is 15, over the hypotenuse, which is the length of AB. Okay. So since that is in the denominator, I'm going to they'll switch places, and the length of AB is equal to 15 over the cosine of 72. And remember, the way you read this is the length of line segment AB. Okay, that's what that is there. So go ahead and let's type that in, get an answer. And we should get 48.541. And make sure that you are typing it in, or you're putting it in the correct box. All right. Everybody okay with all that so far? Okay. So that 48 is quite a bit bigger than 15, but does it make sense that it's bigger than 15 like that? Yeah, because 72 is quite a bit bigger than 18, right? So then we can go find the length of BC. Now, I could use the length of AB to find that. I could do sine with opposite and hypotenuse. Like if sine was your favorite and you just absolutely had to do sine, you could. But you would have to do it with the stored number and the exact value. You cannot do it with a rounded number. You use a rounded number that you have and type it back in, bad things are going to happen and you are going to be wrong. And I will have no sympathy for you. Okay, so if you want to store whatever, that's the hard way to do it. I would say instead, go ahead and go back and use the 15 again and this so we can do tangent. So the tangent of 72 is equal to the opposite, which is the length of BC, over the adjacent, which is 15, so that the length of BC is 15 times the tangent of 72. And then, go ahead and type that in. See what you get. And at this point, you know it should be less than what? The 48.541, right? So what you get is 46.165. So it's less, but it's not that much less. But is that okay? Yeah, I mean, as long as it's less, the fact that this is a small angle here, these two won't be that far off in length necessarily. Okay, did I have a different way I could have found BC also? It's what? You could do a squared plus b squared equals c squared. Is that going to be easier than trig at this point? No, because you'd have to deal with the exact numbers. Because if you type in 48.541 squared, you are going to be wrong. You cannot ever use an intermediate number in there. But if you want to store it and you just absolutely want to do Pythagorean theorem, it's definitely harder than that. But as long as you do it right, you get the same answer. Okay, we good with all that? All right, let's jump to 15. So let's start by finding one of the angle measures. Which one you want to find first, K or L? K, all right, that's fine. Doesn't matter which one, you just have to pick one because then you have to label. So this is the opposite, this is the hypotenuse, this is the adjacent. This is where my information is here, which means I'm using which function? Cosine. So the cosine of K is equal to the adjacent, which is 7.6, over the hypotenuse, which is 8. So then the measure of angle K is equal to the cosine inverse of 7.6 over 8. And now one of the reasons that I was making you wait to type things in on the front is because I don't want you jumping the gun on typing things in the calculator, because you have to get to this point before you touch that calculator. Otherwise, where the heck is your stuff coming from? Okay? So once you've got that, go ahead and find that angle measure. So we get that the measure of angle K is 18.1 what? 95 degrees. Okay, so now when we go and find angle L, can I find angle L by using trig again? Yes. Could I also find angle L by subtracting? Yes. So I can say that the measure of angle L is just equal to 90 minus the measure of angle K. And that's all the work that requires, because you don't need to write the decimals down because you're not typing decimals in. The only time you should ever type a decimal into a calculator is if it was like given to you in the problem. But if it's one that you came up with, you don't get to type it back in. But on these calculators, a couple of ways you can handle this is, let's see if you can actually see what I'm doing here. I want to subtract that from 90. So honestly, what I do a lot of times is I'll just do minus 90, and my answer ends up being negative, but I know it's not supposed to be negative, and it's just less buttons. Or I can do 90 minus, and then down here, you see where answer is right next to the equal sign? You can hit that, and it'll do 90 minus the last answer, which is very similar to what the 83s do. You just kind of find it differently. And then you hit enter, and I hit clear again. Sorry. Hopefully it'll still work. 90 minus, we'll see, answer. I don't know why I hit that button instead of equals all the time. Yeah, there we go. 71.805. Okay. So make sure you understand how to use these things to your advantage. We're good. Okay, so now, to find the length of JL, can I use trig? Yes, I absolutely can. I'd have to use one of the two angles I just found, which means I'd need to store them. Or since I do have one of the angles looking at me in the calculator right now, I just need to be able to push the right buttons to make that happen. But honestly, that might be more complicated than it's worth most of the time. So what's another option here? Pythagorean theorem. So I've got 7.6 squared plus JL squared equals 8 squared. So then the length of JL, if I just do that 8 squared minus 7.6 squared, take the square root of it, won't that give me the length of JL? I don't have to multiply anything. I'm going to use a calculator, so I don't have to actually square any of that stuff. You doing all the intermediate steps and writing that stuff down, that's really just a waste of your time. You can do this all in one step really on any calculator. On this one, it's because it works like the 84s and the Inspires do, where when you hit the square root button, everything you put in there, the square root will grow with it, and you can do it all in one step. So 8 squared minus 7.6 squared. And so it's going to just take the square root of all of that. On your phone, or if you're using an 83, you're going to have to use parentheses if you want to do something like that. But also make sure, I see a lot of people doing squared by using the caret top with the 2. It's not wrong. That still works. Most calculators have a squared button because you use it so much, it just makes it easier to type it in. So once you get all that, and then you hit equals, well, it gives you the exact answer again, right? But how do we get the decimal? The SD button. And there you go. Okay. So we should get, is it 2.498? So make sure that you can actually get that number. And you're good. Okay? Any questions at all? Okay, you got this, right? So review, we should all be good. No big deal. Okay. All right, so go ahead and glue or tape this in, and then I'm going to give you your assignment. Yes, it's only one-sided. That's not a mistake. Okay, you should be able to finish it pretty quickly. You don't need to do 1,000 problems.